Hello, this is FlippedHarber for Algebra 2. In this video we're going to cover section 5.7, Solving Quadratic Inequalities. The objectives for this lesson are to solve quadratic inequalities by using tables and graphs, and to learn how to solve quadratic inequalities by using algebra. The outline for this video, we'll take a look at some graphs of quadratic inequalities. We'll talk about how to solve quadratic inequalities using graphs and tables, and we'll talk about solving quadratic inequalities by using algebra. So, first of all, what the heck is a quadratic inequality? Well, instead of y equals ax squared plus bx plus c, a quadratic inequality is where y is less than ax squared plus bx plus c, or y is greater than ax squared plus bx plus c. Now, when y is less than the quadratic, we're talking about the space below the quadratic. When we're talking about y is greater than, we're talking about all the area on the graph above the curve. Now, here's some graphs of quadratic inequalities. We see the upper left-hand one is y is greater than x squared minus 1. X squared minus 1 is a pretty simple quadratic. It's the parent function moved down 1, and since y is greater than, it means that's all the space above the curve. So it kind of looks like it's all the space inside the curve, but you need to think above and below here. The one on the right, upper right, would be a negative quadratic, so our a value is negative. The area below it is shaded, so this would be y is less than. Now the one right in the middle, down bottom, again, it's shaded below the quadratic. It looks like it's outside, but you really need to think about it as below the quadratic. So it's going to be y is less than. Alright, now let's talk about solving quadratic inequalities using graphs and tables. Now we're going to need to switch the gears up a little bit. I've gone ahead on my calculator as I've graphed our quadratic, x squared minus 6x plus 8. And I'm interested in where that quadratic is less than or equal to 3. So I've also graphed the line y equals 3, and that's that horizontal line. Now we're looking for the points on the curves, just on the curve, not a region of space. I'm not going to shade anything. I'm looking for just the points on the curve that are below y equals 3. Well, obviously it's these points down here. Now, to answer this, it looks like those points start at about x equals 1. And it looks like they stop at about x equals 5. So I think my answer is going to be all the x's between 1 and 5. Well, let's check this with the table. Let's go ahead and plug 0 into my quadratic. We'll plug 1 into the quadratic, 2, 3, 4, 5, and 6. And we'll see if it's less than or greater than 3. So when we plug 0 in, we get 8. Well, 8 is not less than 3. When we plug in 1, we get 3. Well, 3 isn't less than 3, but the statement says that the quadratic should be less than or equal to 3. So 1 works. When I plug in 1, I get 3. 2 works because 0 is less than 3. 3 works because when I plug it in, I get negative 1. That's less than 3. 4 works. Again, 5 works because when I plug it in, I get 3. And 3 is definitely less than or equal to 3. 6 does not work because 8 is not less than 3. So I was right. This region from 1 to 5 does work because when I plug 1 through 5 in, I'm going to get a true statement in my inequality. Now, let's solve this same inequality using algebra. Okay, our first step is to rewrite it as an equation in standard form. So you'll notice that I subtracted the 3 over, and instead of is less than or equal to 0, I just said set it equal to 0. Now I'm going to solve it by any means necessary. Okay, now what I mean is if you want to factor it as I've done here, great. I would totally recommend that you do that. If you want to try to use a square root somehow, if you want to complete the square, that's fine. Any means necessary, solve this quadratic equation. And I get x equals 1 or x equals 5. Now that's not a coincidence. There's no coincidences in math. So that sets up a region from 1 to 5 that might work. But it also creates some regions on the outside. It actually creates 3 regions. Okay? If you only have one solution, that's going to make 2 regions. If you have no real solution, then you have one region to check all the numbers. Now I'm not saying you got to check all the numbers, but if you check one number, it's as good as checking all of them. So our third step here is to plug a number from each region into the original inequality to see if those numbers work. So remember, my 3 regions are the numbers before 1, the numbers between 1 and 5, and the numbers after 5. So, a number from each of those 3 regions. Let's try 0. 0 is always a great number. No matter where it fits in, 0 is always a great number to try. That's obviously going to be from the region before 1. Then I'm going to try 2, because that's a number between 1 and 5. And then I'm going to try 6, because that's a number after 5. Okay, so if I plug in 0, I get a false statement. 8 is not less than or equal to 3. So that's not true. If I plug in 2, I get a true statement. 0 is less than or equal to 3. That is true. When I plug in 6, that's not true. So I get a false statement there, so that tells me that only this middle region works, which we already knew because we solved it with a graph. Alright, so let's try this one. We haven't seen the graph for this one. We haven't done this before, so let's go through our steps. Our first step, we're going to change it to a quadratic equation in standard form. So I add that 9 over, I set it equal to 0. I factor this bad boy out, and I get one number, x equals 2. Now that means that there's only 2 regions to check. The numbers before 2 and the numbers after 2. So if I try a number before 2, 0, 0 is always a great number to try, it doesn't work. If I try a number after 2, like 3, it doesn't work. So no numbers that I can plug in will make this quadratic true. Okay, so now it's your chance to try some on your own. I wish you luck. I'll see you in class and I'll see you online.